Hello, hi, Melissa. Thanks for joining. It's just you for now. I hope you're good. So, welcome to this second lecture in the A Star series. So, what we're going to um, do tonight, we are going to carry on looking at algebra, which was the first lecture yesterday. By the way, even if it's just you who makes it, I don't know if anyone else will turn up. Even if it's just you, I will stick to a lecture format just because these lectures get recorded. This one's being recorded now, and will get uploaded to YouTube. At the same time, if you've got any questions at all, both on the lecture tonight or even just in general, if you've got something on your mind with the course and you want to ask, do take advantage of a opportunity as well. It's no problem at all. And if you do that, you can either put your mic on or just write a question in the messages. Just before I start, I'll just put the link for the last YouTube playlist for the course in the chat. I haven't yet actually set up the one for this new series yet. I think I will probably set that up this weekend, and then I'm sure that'll get updated onto the A Star site very soon afterwards. But this other playlist, you can find the whole previous running of it. In terms of topics, it's exactly the same. The only difference being that within the topics, because they're quite wide reaching, I might focus on different areas. So it can be useful actually to watch the same topics in different series because you might catch different things. Also, going back over the same things can really help. And as always, I'm just going to share my whiteboard on the screen, and we will go through. So yesterday, what we did in class, we focused on collecting like terms in algebra and single and double brackets. So tonight, what we're going to start focusing on is on solving linear equations. And then, depending on time, we may well focus on factorizing as well. Okay, and so a linear equation, or at least in regards to what you need to know for foundation maths, is a two-sided equation. In these questions, you will need to rearrange the equation to find the value of x, or whatever the unknown is. It wouldn't have to be x, it could be any letter, but to find the value of an unknown number. So you do this by rearranging the equation. So I'll just show sort of in a simple form a question like this. So in its most simple form, an equation could be something like this, just like x plus 2 equals 5. So in its simple form, simples sound like a meerkat, but in its simple form, a linear equation could be something like below. And yes, someone looking at this may just sort of instinctively know what it is. You may well be looking at this going, that's really easy. Someone looking at this may instinctively know that x must equal 3 because 2 plus 3 equals 5. But in effect, what you'd be doing to do that, even though you won't be consciously doing it in your own head, is you're rearranging the equation. So what you'd really be doing is taking away 2 from both sides. And so you'd have taken away the 2 from that, so have like x. You'd take away the 2 from 5 equals 3. So basically that's what you're doing. In reality, you are taking 2 from each side to rearrange the equation. Okay, and so I'm going to, before we start looking at individual equations, we're going to talk a little bit about the rules of rearranging equations. It's important to sort of understand this. This comes in not just in solving equations, but rearranging equations as well, which can both be an individual topic, or it could be something like trigonometry or applied algebra where you need to do it on another question. Okay, so the rules of rearranging an equation. So, to get rid of something on one side of an equation, you do its opposite. And so the opposites are as follows. So you have, for example, plus and minus. So to get rid of plus 3, we take 3. So they're like the opposite of each other. Just as we've got the example below, there's a plus 2, and so we have taken 2 away. Okay, so this is me trying to hunt down where the meeting is, because I think I heard someone join. Unfortunately, they've gone away again. But yeah, so in terms of plus and minus, to get rid of plus 3, we minus 3. Then the other ones you got multiply and divide. And it's important to note, often, I'll put the note underneath, but often in equations, division is written as a fraction. So, e.g., to get rid of times 3, we divide by 3. And again, often it will just be, so, note 1, if you see 3x in an equation, it means 3 times x. So therefore, to get to 1x, well, it would just be written all x, you divide by 3. And so often in equations, division is written as a fraction, and so for example, x over 3 means x divided by 3. So to get to x or 1x, we times by 3. So just being familiar with those, realizing why you do the multiplication and division in those situations is very important as well. Well, right, and that's the third type. You see, you don't see it quite so often, but it might come up late in the exam. And the third opposite are powers and roots. Powers and roots. So, for example, to get rid of x squared, we square root, because square root is the opposite of x squared. Now, there is another key rule as well. I'm going to put it down here, and that's a bit weird going from right to left. I want to fit on the same rule. So, the other vital rule when rearranging equations is whatever you do to one side, you do exactly the same to the other. So therefore, for example, here we've got x plus 2 equals 5. Well, we took away 2 from one side, so we take away 2 from the other. If it was 2x equals 6, we divide by 2 to get to x, so we also divide 6 by 2. So whatever you do to one side, you do exactly the same to the other side as well. Okay, we're going to go from here and look at some examples. And what it will be with these examples, by the way, if you need me to go back for a slide, anyone, please just let me know. It's not a problem at all. In terms of these examples, we're going to look at different types which get progressively more complicated. So type 1, so we've got types of linear equation. So A, we've got 1 unknown. And so these are the simplest ones to deal with. So let's say we've got 5x minus 3 equals 27. And so to solve this, we first need to rearrange to get the x's on their own. To do this, we must get rid of the negative 3. So remembering what we said on the previous slide, we've got negative 3 here. We need to do the opposite of that. So the opposite of negative 3 is to add 3. To add 3 to both sides. And then whatever you do to one side of the equation, you've got to do exactly the same to the other side as well. So we need to do 27 plus 3. So we've got 5x equals 30. And now as 5x means 5 times x, we need to divide by 5 to get to x, or to get to 1x. And so whatever we do to one side, we do exactly the same to the other. Then we divide by 5. And so that's going to give us, well, that gives us x on this side equals 30 divided by 5 equals 6. 30 divided by 5, so x equals 6 is your final answer. Now, I don't normally do this, but just to explain, if you are correct, you can input your answer in the first equation and it will balance. So for example here, we'd have 5 times 6, take 3, well, 5 6s are 30, take 3 equals 27. Oh, right. So relatively straightforward at that stage. I'm just going to show as well another example with one unknown to show how it could be, it could potentially be different. So as one I explained before, that you just want to be aware of it. So we've got question 2, solve the equation half x minus 3 equals 7. So the key thing here, so first we still must get the x's on that. And so the way to do that, we've got half x minus 3. Well, the opposite of minus 3 is, of course, plus 3. Whatever you do to one side, you do exactly the same to the other. So we're left with half x equals 10. And so what you need to remember half x simply means the same as 1 divided by 2x. So therefore, to get to x, or to get to 1x, we do the opposite, which is to multiply by 2. So we can do that here. We've got half x equals 10, so we can times by 2, and that's just going to leave us with x equals 20, because whatever we do to one side, we do exactly the same to the other. So as long as you're familiar with them, questions with sort of one unknown aren't normally too horrible, to be honest. I generally tend to be relatively okay. But we're going to move on now to a slightly more fiddly one, which is just an unknown that appears more than once. So here, yeah, so the unknown appears more than once. And so on these questions, you need to first rearrange so that the unknown is only on one side. Once you have done this, we can follow the stages from type 1. Okay, so I'm going to copy across a question here. And this is where people often start coming unstuck if I haven't truly understood it, or they can get a little bit intimidated and stop following the rules. But all the rules we've discussed, they still apply. But we got solve 12x plus 8 equals 5x plus 36. All right. And basically, to rearrange, we need to take away the x's from the side with less of them. So it doesn't matter if it's the x's on the right or the left. And to be honest, even if you took it away from the other side, you could eventually get to the right answer, but it would make your life much more complex as you'd be dealing with negative numbers. So here we want to take away our x's from the side with less of them. We've got 5x on the right, 12 on the left, so we're going to minus 5x. And we're not dividing here because we don't want to get to 1x, we want to get to 0 at this stage. So we've got positive 5x, the opposite of positive 5x, negative 5x. So we take away the 5x. Now remember, whatever we do to one side, we're doing exactly the same to the other. It's not we're taking from one to give to the other, we are taking the 5x from both. Like a linear equation, it's kind of like a scale. You've got to keep it balancing at all times, and the only way to keep it balancing is to do exactly the same thing on both sides. So 12x take 5x gives us 7x. The numbers aren't going to change. So we've got 7x plus 8 equals 36. And so now what we've got to do is now follow the same stages as before. So we've got 7x plus 8 equals 36. Well, the opposite of plus 8 we can do is minus 8. Is minus 8. All right, and so that's going to leave us with 36 minus 8 equals 28. So we can get to 7x equals 28. And now remember 7x means 7 times x. We can do the opposite of times 7, which is divide by 7. And it's going to get us to a final answer of x equals 4. All right, so as you can see, it's sort of the same as before, but just with that additional stage on the top. All right, so we're going to carry on and look for another example. So next we're going to look at type 3. Which is equations with a bracket. And so sometimes you will get a linear equation with a bracket on one or both sides. In order to solve this, we must expand the brackets using the skills we did in yesterday's class before we can continue. Expanding brackets is simply rewriting information, so has no effect on the other side because it's not actually getting rid of anything, it's not taking anything away or adding, it's just rewriting it. But yes, show an example down here. So we've got 2x plus 4 equals x plus 10. And so what we need to do is to multiply out the bracket. Just remember, the way you multiply a bracket, you multiply everything on the inside by what's on the outside. Going from left to right, first we're going to do 2 times x, which just gives us 2x. And then we are going to do 2 times 4, which gives us 8. And that gives us an equation down here of 2x plus 8 equals x plus 10. And so now we've done this. Now we're back on familiar territory. And so now we can just follow the steps as before. So what we want to do next, we want to get the x's, so they're only on one side. So we get rid of the x on the side with less. Well, remember, x just means 1x. We're going to take that away. 2x take 1x gives us x, 1x. So x plus 8 equals 10. So next we need to rearrange to get, in this case, it's 1x. It's the x on its own. So we need to take away 8. And so x equals 2. And so in this case, just to make clear, hopefully it makes sense, but we already have 1x, so there is no final stage. Just finishes as x equals 2. All right, so we're going to move on now, look at another couple of examples, and then we're going to move on to a new topic. I'm going to look at next with type 4. Type 4 questions where the entirety of 1/both sides is over a fraction. Okay, and so this is different to having an individual fraction like half x, so like the one we saw earlier. This is when a whole side is under. If a whole side is over a fraction, we need to multiply by the denominator to get rid of it before doing anything else. So remember, like the denominator of a fraction, it means like divided by. So if a whole of a fraction is over a denominator, that means the whole of the fraction is divided by. So let's hunt down an example now. So we've got here, I'm not sure this example might give a bit of a horrible answer, but we'll cross that bridge when we come to it. Sorry, it's just got appropriate as well, the bottom of but we've got 3x plus 2 over 2 equals 6x plus 4. So what we must do first is to get rid of divided by 2, we must times by 2, as the whole of the left will be multiplied by 2, the whole of the right must be 2. And we can show this by putting it into a bracket. So you could multiply the individual things at once, you could skip this stage, or you could bring back. So we've got divided by 2, we want to get rid of that, so we're going to times by 2, and so that's just going to leave us with 3x plus 2, because we've got rid of the fraction, we times by 2, equals 2 times 6x plus 4. All right, and so now we've done that, now we can continue the question following our previous steps. Okay, so if I write out here again, we've got 3x plus 2 equals 2, 6x plus 4. So we need to multiply out this bracket. So you can do 2 times 6x equals 12x. And then we can do 2 times 4 equals 8. So now we've got 3x plus 2 equals 12x plus 8. So what we can do next, well, this time we've got the more x's on the right, and so we need to take away the x on the left. So we're going to minus 3x, and that's going to leave us with 2 equals 9x plus 8. And just to say, so note, if you prefer to have your x on the left, you can simply flip the question. Let's see if I can fit it all on this line here. Question And so what I mean by that, you could just rewrite this round the other way round. For whatever reason, I prefer it that way round. So you can do 9x plus 8 equals 2. Well, now what we've got to do next, we have got to minus 2. So we've got to minus 8 because we've got to get our 9x on our own. And if you minus 8 from both sides, you're going to be left with going to put this as stages actually just to make it a little bit clearer. So we've got A, we've got B, we've got C, we've got D, we'll put here E. So you're just left with 9x equals minus 6, because 2 minus 8 gives us minus 6. The reason I want to give multiply is to explain this. So if your division at the end won't give a whole number, you can simply write it as a fraction. So this won't come up too often. As I say, it's a bit of a horrible example. It's a good thing to understand if you do. Just as I said before, something written as a fraction and division is the same, but a fraction is also a way you can write this, because here we've got minus 6 divided by 9, which doesn't sound nice to anyone. But you could just write as x equals minus 6 over 9. You could even simplify it to x equals minus 2/3 if you want. We're going to leave it as x equals minus 6 over 9. So you see we've just written, because that's basically what the fraction means, minus 6/9, but it also means minus 6 divided by 9. So it's a completely reasonable way to answer at the end if you're dealing with a horrible number. As I say, hopefully you won't get one that nasty in the exam, but it's worth mentioning just in case. All right, so move on from that. What we're going to show next, we are going to just show one more thing, which is we're going to say is solving an equation where x is squared. And it could be x is cubed as well. It could be anything that has a power. It's most likely to be x is squared. So for these questions, we need to do all the stages to get to, I'm going to leave a gap to write this here, before we get rid of this by square rooting. That's how we get rid of it. And this is the square root sign. This is what x squared looks like. So yes, give an example here. And generally, if you see one of these questions, it'll be something like this. It's not going to be some long-winded, complicated question. It's just going to have a big, so really testing your knowledge of this. This could still be, if you've got something like this will be right at the end of the exam, to be honest, because it's got a little tricky bit to it, which I'm going to explain as well. But the first thing we need to do is to divide by 5, because we want to get to 1x squared. And 320 divided by 5, I wouldn't expect you to just know it. You should do a long division if you need to, but it equals 64. You got that right, so we ended up with a nice square number. So now we need to do the opposite of squared, which is square root. But this is where a little trick comes in you need to be aware of, because the square root of 64 could be 8 or minus 8. We need to represent both. as we have no way of knowing. You could have a question with this way. You do have a way of knowing. Say if it's a measurement at the end, where it often is on questions like this, then it has to be positive because you can't have a negative measurement. But in this case, we've got no way of knowing. So what you would write is, well, the square root of 64 equals 8. So we would just do x equals plus minus 8. Okay, and so the plus and minus represent that it could be positive or negative. All right, so it's a topic solving equations. It can be a little bit fiddly. Definitely take some practice. I recommend trying to look up some questions, go through at each stage, making sure you are confident with it. But those really cover the gist of them. The main things that will come up in regards to that. There might be some tiny differentiation, but it's for the vast majority of stuff we've covered here. But next, what we're going to look at is factorising. So factorising, and so this is the process of putting an equation into brackets. So it is the opposite of expanding brackets, which we did yesterday. So I'll be honest, it kind of frustrates me a bit. This is in the foundation because at this stage of maths, it's going to all feel incredibly pointless. It has a really important purpose when you're solving equations, when you're dealing with equations later on, but you don't get to any of them until at least you're in higher maths. So at this stage, it's just a case of really learning the processes, really understanding them. All right, and so we factorise an equation by finding common factors. And so factors with numbers are basically numbers in common between two. So number of factors are numbers that go into another number. So say you've got 10, the factors are 1 and 10 because 1 times 10 equals 10, or 2 and 5 because 2 times 5 equals 5. But equally in terms of this, factors by finding common factors. So a factor equals a number that goes into each other, and so a common factor equals a factor for the number or a letter in common. We'll see that as we go exactly what I mean. I realise it's not the most hidden thing, but a common factor equals a factor in common. I've really defeated the mysteries of maths there, but hopefully it will make more sense as it goes along. But we'll give a sort of equation. You might get a bit like sorry about this, or at least we will if I manage to copy it successfully. So that I'm going to do it up here. So we'll say sample. So we've got factorised fully 10pq plus 15pq. So to do this, we need to find the highest common factor, the highest number that goes into both 10 and 15 and any letters in common. Now you can do this by writing out just all the factors for both, so doing like 1 times 10, 2 times 5, 1 times 15, 3 times 5, or you may just be able to see it relatively simple when you're dealing with smaller numbers, which is obviously quicker. So you've got 10 here, and we've got 2 times 5, and then we've got 15, and we've got 3 times 5. So the highest common factor between the two numbers is 5. And also the number you've multiplied by to get to 10 or to get to 15 is relevant as well when we write out to brackets. So always circle the HCF for highest common factor and underline its factor pair, then circle any letters in common. So in this case, the letters are fairly straightforward because we haven't got any powers to deal with. So we've got P and Q on the top, we've got P, Q and R on the bottom. So we've got P in common and we've got Q in common. And so now we can write out equations. So now on the outside of the bracket, we put our HCF and any letters in common. And then on the inside, we put factor pairs, any remaining letters, and the sign from the initial question. So here, where we've got the highest common factor, how many we've got is 5. Then we have got P and Q in common, and then in our brackets, where the factor power of 10 is 2, the sign from our initial question is plus, then the factor power on the last one is 3, and we've got an R. So our final answer would be 5PQ in brackets 2 plus 3R. And what you could do as well, if you wanted to double check it, I'm not going to do it here because of space, but you can multiply out the brackets. You could do 5PQ times 2, which gives you 10PQ, 5PQ times 3R, which gives you 15PQR. So if you do that, you're going to end back up where you started with 10PQ plus 15PQR. All right, so let's look at another couple of examples for this. So next, what we're going to look at is here we've just got one with a couple of extra things going on. So so actually, no, what I'm going to show you next, because I often see the ones on the example page are often more complicated. But in the exam, I often see ones which, on the one hand, are more simple, but they can throw people off. So factorizing into single brackets when there is no HCF of the numbers. So e.g. factorize fully we're going to put in, we're going to have x squared y minus 3xy. And so in this case, we can't factorize the numbers as the first term is only 1. However, we can still factorize the letters. Remember, a power tells us how many of a letter that is. So we've got x squared y in effect equals x y, and then we've got 3xy down here. So what have they got in common? They've got 1x and 1y in common. So it's just going to come down here. Outside our brackets, we will have x, y. In fact, we've got just x. In this case, it's a minus in the equation, so we've got a minus to be x take 3. Now we're going to do one more example of this. So we're going to do so factorizing into single brackets when there are more than 2 terms. And so for these more fiddly questions, the process is exactly the same. We simply need to find factors between all terms. So here we'll say, like, e.g., copy a question down here. So we've got factorised fully 4xy5 plus y5 plus 12y. And so, although 4 goes into 12, as our second term doesn't have a number, we again can't find an HCF for the numbers. All the HCF in effect is 1 because all of them will be 1, but that doesn't do anything. So we're therefore just dealing with the letters again. So we've got in common all of the terms have 5y in common, which is all there is in our middle term, of course. So we've got 5y here, we've got the 5y here, and we've got 5 of us ny here, so it becomes y2. And so what it becomes, and I'll put a note underneath to explain it, we're going to have y5 outside our brackets, then we have what's remained, so we have 4x plus, now we still need to have something here, I'll write a note underneath, but we're going to put 1 here, because the y5 has to multiply by something to get to y5, otherwise there'll be nothing there, and we got a 12y2 at the end, so I just put a note to that. Right, as there is nothing left for our second term, although, sorry, for our second term, we still need to include the 1 which was initially invisible, because there's a 1 there to start with. It's 1y5, we just wouldn't normally write the 1, the 1's still there, so we need to include that to have something to multiply the y5 by. All right, so that takes us to the end of the topic. I'm not going to go into double brackets today because of time, and it may be in this course, as I say, it can be a little bit different between one and the other. I think we might get through a few. We'll probably do this time round. We're going to have ended up doing fewer of the algebra topics during the course, but probably have done them more in depth. But the final thing we're going to focus on today, because it links into resolving equations we've already done, is inequalities. Inequalities. So inequalities come up in a couple of ways in the exam. So you have number lines and you have inequalities to solve, which follow exactly the same rules as solving an equation. So we're going to begin with A, inequalities on a number line. And sorry, I should mention as well really what is an inequality. So an inequality is a question where the unknown, or where x is greater or less than something. And this is shown with the following signs. Sorry, I'm going to get rid of this bit which says inequalities on the number line. For now, we're going to do that on the other side. But here we've got following signs. We have got here, you will see with inequalities, you'll see this one, or equally, you will see this one. And so the top sign, it looks a bit like a crocodile. In fact, I'm going to write it further along so it makes it clearer. Sorry about this. We'll do it slightly different. You've got this side, which on this side it means less than, and where the crocodile mouth is open, it's greater than. And you've got the other way, which is with the line underneath, and then it's less than or equal and greater than or equal. So hopefully these signs will ring a bell from school days as well, but if not, it's definitely worth learning them as well. And so this is also shown, I should say, an inclusive inequality, one which includes equal, is also shown with a black circle and a number line, and the inequality which doesn't include equal than is shown with the white circle. All right, so let's go here. We've got here inequalities on a number line. And so we've got below, e.g., what does the below inequality show? So you might get an inequality like this, where we have got a line here. We would normally say as well, I'm going to add a detail down here because it normally gives us down in the corner a letter. So, all right, so we know from this our letter will be X. We know it must be greater than where our circle is, because our arrow points to bigger numbers, and we know it is equal to or greater as we have a closed circle or a black circle. So that means we can write it out. What our answer would be, you say x is greater than or equal to, and our circle is above -5, so -5. Or you could write it the other way around. You could have -5 here, the arrow's the other way around, and x doesn't matter which way round. So just give another example, which is so EG2, which is a number line with 2 circles. She could have as well. And so we've got here, let's say our letter, we'll call it a different letter just to mix it up. So we'll say Y. And we know here we've got the 2 circles. So we know that Y will be in the middle, and Y needs to be smaller than something, and it has to be greater than, and because it's a closed circle here, this one's greater than or equal to. So we know, because it's a closed circle, but Y is greater than or equal to -3. We know because it's an open circle, but Y is must be less than 5. So I've written that arrow the wrong way around with Y there. I do apologise. I will correct that. But of course, the open it has to go to 5 because 5 is greater than Y. So it would look like this: -3, then Y in the middle, and then 5 is greater than Y. We know Y must be greater than or equal to -3, but less than 5. All right, so just going to show you a final example from today with inequalities, and that's just solving an inequality. Okay, so solving inequalities, you may be asked to solve a two-sided inequality. This works exactly the same as solving an equation. The only difference is the sign in the middle. Okay, so we'll put this here. We've got solve the inequality. 5a minus 4 is greater than 2a plus 8. So what we can do here, basically, it's no different than if the sign was an equal. So first we need to rearrange to get the unknown on one side. So here we've got 5a on one side, we've got 2a on the other. So we can minus 2a, minus 2a. Well, 5a minus 2a, that's going to leave us with 3a minus 4 is greater than 8. So you can see it's no different than if it said equals. If it said equals, we've done things exactly the same. Now we need to rearrange to get the unknown on its own. So we've got 3a minus 4. We've got to do the opposite of minus 4, which is plus 4. Again, whatever we do to one side, we do exactly the same to the other. And so finally we've got 3a, so we need to divide by the amount of the unknown. The unknown. In this case, it's a. It makes no difference what the letter is. I know normally it's x, but just because you get a different letter, the process doesn't change. So we need to divide by 3, and we just got a is greater than 4. So you can see this is no different than if the question said it equals. The only difference would be your final answer would be a equals 4 as opposed to a is greater than 4. But the process is exactly the same. All right, well, I'm going to leave it there for tonight. Thanks a lot, Melissa, for making it along. Would have been a bit of a lonely record without you, so I do appreciate you making it. And yeah, I hope you have a brilliant week, and hopefully see you back here. We'll be back normal time, so 7:15 next Thursday and next Friday. All right, thank you very much. Have a good night. Yeah, you too. Bye bye. All right, bye bye.